Ever tried walking through a wall? Doesn't work, right? You walk up to it, maybe give it a push, and then realize it's just not happening. The wall is solid and you're solid. So you bounce back or stop in your tracks. It's a fundamental experience of our everyday lives. But what if I told you that in the microscopic world, things work a bit differently? In the quantum world, particles do it all the time. They don't just stop at barriers. Instead, they have this incredible ability to pass through them as if the barriers weren't even there. This isn't some sci-fi fantasy. It's a real phenomenon observed in the realm of quantum mechanics. This is called quantum tunneling. It's one of the most fascinating and mind-bending concepts in physics. Quantum tunneling defies our classical understanding of how particles should behave. Imagine an electron facing a solid barrier. In our everyday world, if you throw a ball at a wall, it bounces back. The same should happen with an electron, right? In classical physics, it should stop, like you hitting a wall. The energy of the electron isn't enough to overcome the barrier, so it should just bounce back. But quantum mechanics says particles are also waves, and this wave-particle duality changes everything. Particles like electrons aren't just tiny balls, they have wave-like properties, and waves can extend beyond barriers. This means that the wave associated with the electron doesn't just stop at the barrier, it spreads out and can penetrate through it. If the barrier is thin enough, part of the wave gets through. This is where the magic happens. The electron, as a wave, has a probability of being on the other side of the barrier. And boom! The particle tunnels through, appearing on the other side as if it had walked through a door. This happens even though it didn't have enough energy to climb over the barrier in the first place. This phenomenon is crucial for many processes in the universe. For instance, in the core of stars, including our sun, quantum tunneling allows nuclear fusion to occur at temperatures and pressures that wouldn't be possible otherwise. Without quantum tunneling, the sun wouldn't shine, and life as we know it wouldn't exist. The energy produced by the sun is a direct result of quantum tunneling in its core. And it's not just the sun. Modern technology like semiconductors and tunnel diodes relies on quantum tunneling. So next time you use your smartphone or computer, remember that quantum tunneling is at work. Mind blown? Subscribe for more.